Hello and welcome back to Mars. I'm Mick, we're playing Stationeers. Now as you may have guessed, today we're in a greenhouse. We're going to do a bit of gardening. Now I've had this all set up for quite a while, but like most gardening in real life, I just leave it to the last minute and only do it when I really have to. But today's the day we're going to do it. Now we've got our Harvies set up. They are our automated plant grower thingies. Now, as I say, I hate gardening, so if it's not automated, I don't want to do it. And Harvey's there to help us do it. At the moment, he's pretty dumb, not going to do anything. We've got to program him. So we got some ICs set up, and we are going to make them work for us. To get Harvey to plant, it's kind of a team effort between the Harvey and the hydroponics device. Now, the hydroponics device is different to the hydroponics tray. Now the hydroponics tray is your basic one there, but using your scroll wheel, it turns around to a hydroponics device, which actually has a data port on it. The hydroponics tray's got nothing, hydroponics device. Now we want that data port because that's the thing that's going to tell us what's going on with the plant inside. We can find our hydroponics device and we can see that it has slots on it. Now slots are sort of hidden in there, which don't show up on our device reader, but in our logic slots we can see that we have a value called mature. Now the value of mature is going to tell us, well, if the plant's mature or not. So we can hook up a slot reader and have a look. Now if we jump into it and have a look, hydroponics device 1, we can look into slot 1, there is only one, and whether or not it's mature. We find it has a value of 1. So it's mature. If we go to hydroponics device 2, slot 1, we switch to mature, it's 0. So 0 for an immature plant. Device 3, slot 1, mature is -1. So -1 is an empty tray. So they're the things we're going to have to test to decide whether or not we need to harvest it, wait a bit longer, or plant something. So here's the code we've got here. Now we'll start by defining a few setup values here. We've aliased our register 1 as a mature variable. That's just where we're going to store the value from our hydroponics slot as to whether or not the plant's mature. We've defined our input slots for our plant and our input slot for Harvey. That's just to make the code a bit easier to read. We don't have to do that at all. Now we've aliased our hydroponics to D0 and Harvey to D3. That's just the top 2 pins on our chip. Now, into our main loop here. First thing we do is sleep for 4 seconds. Well, plants don't grow in a big hurry there. It's kind of like watching grass grow. But it also gives a chance for whatever we've asked it to do at the end of the program there to complete its actions so that it's all reset by the time we start again. So, first thing we do up is we load from the hydroponics plant slot the mature value and store it into our register that we set up earlier in mature. Now from our earlier test, if that value is 0, just go back to the start. It means it's not mature. You don't have to do anything, just wait a bit longer. So it goes back to the start, sleeps a bit longer. Now if it's equal to -1, it means there's no plant in there. So we have to go down to our plant routine and plant the plant. If it's neither of those two, it must be a 1. That means that the plant is ready to harvest. So we can just save to Harvey the harvest command, set that to 1. We'll see in our set of device variables over here, where harvest does belong to Harvey, and it is a command to make them harvest. So our plant routine. Now Harvey does have a bit of a bug at the moment that if you keep telling him to plant something when he doesn't actually have anything at the input slot to plant, he'll eventually just bug out and not move anymore until you grab your drill and rip him down and reinsert him. So before we actually tell him to plant something, we are going to check the slot on Harvey. Now we can find out from Harvey, once again from our Stationepedia, if we look up Harvey, we find out that he does have a slot, import and export slots. Now it's the import one we're interested in here because that's where he holds the stuff that he's still got to plant. and if we find from our slots there, they do have a quantity value down here. So that's the one we'll be looking at there. So we are reading from Harvey the input slot, which was 0 we defined up here, the quantity, and we're loading it into our register R0, just our temporary value that we'll just throw away the next line. If there's 0 in there, nothing to plant, we go back to the start, do nothing. If it does have something to plant, then just set plant to 1. Once again, we find plant in here is something specific to Harvey, which will give him an action to plant the thing. So we just set it to 1, plant. He'll go through his planting routine and reset his plant value. So he then has 4 seconds to complete that, and then we're on to the next round there to see what's happening. So confirm that. If we export it, it's over there. Harvey is doing nothing. We give him something to plant. Let's wait for it. Plants it, and he's now happy. He'll wait now till that grows, and then he'll harvest it. So that is Harvey simply automated, but we've got a lot of Harvies there, and I don't want to have to put in another chip for every single one of them. See, we have actually only used 2 pins to do that one. So I can actually hook up 3 different Harvies to this to do the same job from the one chip. So that's what we'll do now. So we'll do a couple of tricks where we actually, instead of writing more code to do it, well, I suppose we will write a bit more code there, but instead of actually writing a routine to handle each of those ones individually, I'll write a function that can handle one, and then I'll just re-alias the name Harvey and hydroponics and just get it to reuse the same code for each one of them. So in our code, I'm going to change this one to be a function, and I'll create a new main loop around our aliases. Our main loop here now aliases our hydroponics, then calls a jump to our check hydroponics command. So now it's a JAL, so it's a straight jump which stores our return address of 10 into the register RA. So we jump down to here, and once it's the same, we load the slot for the plant mature. If it's not mature, we jump back to where it came from. So instead of jumping back to the start, we jumped back to RA, which was the line where it came from. So we jump back to there, which it sleeps, go through again. Once again, all our returns have just gone back to RA, so return to where you came from. Same on the rest of it. So now the trick comes, is now we re-alias our hydroponics and our Harvey and repeat the process. So here's what we've done here. We've just copied these 3 lines of code again and again. Where we had hydroponics to D0 and D3, we've then gone and performed the function to do all the planting, and then we've just changed it. We said hydroponics is now D1 and D4. So it'll go from checking the top 2 pins to the middle 2 pins, then do the same piece of code then. The code will carry it out thinking that hydroponics is now D2 and D1 and D4. So then once again it comes back to here and we check again. We change them to D2 and D5, the bottom 2 pins on the chip. And we run back into the function, which will then come back here, or sleep for 4 and start all over again. So it'll check through the first one, second one, third one, wait a bit, then go back and check them again. So it'll just keep doing that through all 3 sets of them. So if we confirm that, export it, and away they go. So we've got the whole lot of them happily operating now. And if you've got 3 of them hooked up, that's fine. Well, what if you've got 2 of them hooked up? You don't actually have a 3rd one yet. Well, there's a way we can go about that one too. So if we go into our command, now when this device is hooked up, it'll expect one there, it'll expect another one. If any of them aren't hooked up, it will throw an error. But we can do an error recovery process in here. So we'll define them as 1 and 2. Then when we go to check hydroponics, the first thing we'll do is we'll check to make sure that they are actually attached. So we can actually branch, if device not set, to to hydroponics, just return. And we can do the same for Harvey. So now if these devices are set, it comes down to here, it does it all. If either of those two are not set, it immediately just throws it back. Before it tries to use the devices and creates an error, it'll just throw the code straight back into where it came from and continue on. If they're not there, it gets down here, realizes that, and throws straight back. So that will still function whether you've got just one set, two sets, or three sets. Doesn't matter which pins you've got them connected to, as long as they're in pairs, you're good. So that's a handy little error recovery technique with there. Just branch if device is not set. Okay, we confirm, we export. It's still happy. Well, not doing much at the moment. Hurry up and grow, plants. Right, so another thing we can actually test though is if we look at our hydroponics thing, if it works, we can see that it does have all sorts of things in there for actually testing the water. So it says how much water is there, the temperature, whether it's got any pollutants or volatiles in it. Now on the patch notes it says plants are a lot more sensitive to pollutants and volatiles in the water. I haven't been able to find out exactly what concentration it is, but it's something we can test for. So we'll just say if there's any in there, you probably shouldn't be planting it. If it's too hot or too cold, you probably shouldn't be planting it. And if there's no water there, you probably shouldn't be planting it. So we can run a few extra tests on that just to make sure. Here's what we've got for it. So in the plant routine, just after we test if Harvey's got anything to plant, yeah, it's got something there to plant, it's fine. So from the hydroponics tray, we will load the temperature, store it in our temporary variable R0. Now, if it's less than 288, which is 15 degrees C, that is not suitable for planting, so just get out of there, go back to the start, don't bother going any further. If it's greater than 50 degrees C, which is 323, that's not suitable for planting. Just go back to the start, don't plant anything. If the ratio of water is less than 1, so if it's not 100% water, just go back to the start. Don't plant anything. So there's something else in there you shouldn't have in your water. It's not good H2O. Then we check the total moles. So if we got this far, it is water in there. That's all we've got is water. It's at the right temperature. So let's just check the total moles. Make sure there is some water actually there. So from the hydroponics, we load total moles into R0. If it's equal to 0, well, there's no water there. We can't grow anything. So back to the start. If it survives all of those tests, then we can plant something. So that'll make sure it's safe to plant. Well, that'll make sure the water is safe to plant. So if we can export that. Well, they're not ready to do anything. So now I do have a few sets of Harvies there. Now I can load that code into all of them there. If we want to test the atmosphere, there is nothing on Harvey to test the atmosphere to make sure there's carbon dioxide here or the room's warm enough. There's nothing there to test if there's light. There's nothing there to test in either of them, if anything other than the water is suitable for planting. Now we can hook up a atmospheric sensor to it. That will allow us to test the atmosphere, but that'll use up one of my pins, and I would have to hook up a separate atmospheric analyzer to each one, or the same one to each one, but I'll have to put the code in each of them. So I do actually have a way around that, because I have a separate system over here which is looking at the atmosphere and controlling the temperature. So I might be able to use that to then tell these ones which ones are ready to, whether or not it's safe to plant. I can do that by getting that one to write to the housing on each of these ones and set the housing to say 1 if it's safe to plant or 0 if it's not safe to plant. Now the code we've added here is just at the start in our setup area. I've just saved to the DB housing setting 1. So it will automatically say from the very start that it is safe to plant. Now I'll put that there just in case you don't have the second chip hooked up, so we want to make sure that by default it will start planting. As part of our plant routine down here, I've just checked the DB housing just loaded that to R0 and checked and see if it's equal to 0. So if it is equal to 0, something else has changed it to 0, meaning it's not safe to plant. But if there's nothing else connected, it should just stay as 1 and it'll plant. Right, so there, confirm, we export them, and all our devices are hooked up, they should all be going. So now it's just a matter of modifying our other one to find out if the temperature or the carbon dioxide or pollutants or hydrogen in the atmosphere are too high of a concentration. We've got a gas sensor here, that will get it all to us. Then I can just use a batch write command to write it to all of the housings, and we should be good. So I am using a batch write command to write to the housing, so make sure that your greenhouse is isolated from the rest of your base via a transformer or an APC or something there, because you don't want that signal going out to every single IC housing in your entire base. So here we have the code for controlling the temperature in our greenhouse. We have a heater, cooler and our sensor attached to D0, D1, D2. We've aliased our temperature to R0. We've just set some constants with maximum minimum temperature. We load the temperature from the sensor and store it into our variable temperature. Compare it to the minimum temperature, store that in temperature R0. Now we either switch the heater on or off, then we compare it to the maximum temperature, switch the cooler on or off. So that controls the heaters. We can just follow on from the bottom of that code and add in a few more tests to decide whether or not it's safe to plant. Here's what we've added. Now we've already loaded the temperature, so we just tested if the temperature is less than 288, which is your 15C, it's not safe to plant. So jump down to not safe and it sets the housings to 0. Right, if it's greater than 50 degrees, 323 Kelvin, it's not safe. We load the carbon dioxide. If there's less than 1%, it's not safe, because we need 1% for the plants to grow minimum. Now the pressure, we load the pressure from the sensor. If the pressure is less than 20 kilopascals, it's not safe. If the temperature is greater than 140 kilopascals, it's not safe. We load the ratio of volatiles. If it's greater than or equal to 1%, it's not safe. We load the pollutants. If it's more than 1%, it's not safe. If it passes all those tests, then it is safe. I think I've got them all. And we set the dB housing to 0. We're using an SB, which is a save batch command. A dB housing we can get from Stationeries. dB housing has a prefab hash there. We've just set that to find that as a constant up the top, so it's just a bit more readable in the code. Now, so that's what we've set up. So if we meet all those, now I'm not 100% certain on what these values are here. I can't really find much information on it, but I know the Martian atmosphere is 0.6% pollutant, and things seem to grow quite well on that, so I've just put it to 1%. They may be right, they may be wrong. I'll have to adjust them later on as I find out, I guess. But we've done all our tests. If it passes all of them, we set the dB housing to 1 to say it is safe to plant. If we fail any of them, it immediately goes to not safe, sets the dB housing to 0, and when it goes to plant, it will spot that and not plant. We confirm, we export. Now if we look at our dB housings, they have been changed to state 1. When I point at them with the hover over it with my pointer, state 1 and state 1. So it has set them all to state 1. It's still controlling our heater and cooler. It's doing its job. There we have it. Full set of automated Harvies, fully protected from our water supply and fully protected from our environment here. Automated hydroponics, done. So, till next time, happy building. See ya. One last thing, we have a batch slot reader. It's connected to the hydroponics devices, the plant slot, and we're reading the quantity, the maximum. So if any of those has a plant in it, this will read 1. Switch it on, it reads 0 because there is nothing in any of them. Our batch writer is connected to the slot reader. It is reading to our grow lights, and our value will be on. Switch it on, it's right to 0, the grey lights are off. Now as soon as we plant something, if we can get Harvey to get to work for us, plant it, on come the grey lights automatically. So when there's nothing to plant, they'll just automatically shut down. Well, that'll save us a heap of carbon emissions on our power bill, because we wouldn't want to create a greenhouse. No? Shut up? Stick to building? Fair enough.